Good afternoon, everybody. Welcome to reInvent 2018. Welcome to reInvent Monday. Hope you guys have a phenomenal agenda-packed week ahead of you. It's my pleasure to welcome you to ARC333, which is From Russia with Love, Fox Sports World Cup production. On stage with me today are going to be two presenters. Our customer speaking today is Fox Sports, and we've got Brandon Potter, who's Director of Post-Production at Fox Sports, to speak. We've also got Mike Flathers, who's CTO of Aspera, to also talk, and they'll be both joined by myself to talk through World Cup production, which I think is a super exciting evolution of the use of the cloud for an extremely high-profile event that hopefully many of you watch. I see a show of hands as to who watched the World Cup. All right, nearly everyone. It's pretty hard to miss, right? So this is pretty exciting. And I've been at AWS for about 6.5 years. It's wonderful to be able to tell stories like this where our customers are truly innovating around what they can do in terms of viewer entertainment and differentiating themselves about what they offer from a content and experience perspective. And it's really exciting to see how our technology partners and the AWS platform are being used to really help that reinvention and keeping TV very relevant around events like this, specifically things like the World Cup. So our presentation is split into 3 sections. So we were thinking about how to articulate this. If you're involved in live event production or you're involved in broadcasting, you'll know the complexities involved in servicing all of your internal stakeholders, dealing with all of your external service providers, dealing with all the technology components that you need to piece together to get something to work. And what we're going to step through today is essentially how, with an event going on in Russia, which Fox Sports was the official broadcaster for the United States. Russia is 6,000 miles away. It's 10,000 kilometers. It's about 180 milliseconds over a network. So it's really far. And what we're going to talk about is how that gaming and that programming was brought to the US, where Fox Sports is based, how it was presented to their editors, and how it was inserted into their live programming for the duration of the event. And so we've got 3 sections. So Fox Sports is going to come up on stage and talk about the production aspects, which is quite a unique insight into the complexities that we go through as technology providers in providing the plumbing, providing the software, providing the glue to really enable a production and essentially what your viewers see on their screens or their devices at home on mobile. I'm going to talk about the AWS infrastructure that was involved in facilitating this. And so this is both the AWS networking components, the different regions, serverless technologies, EC2, compute, things like that. And then Mike is going to come up on stage from Aspera to talk about the video transport and really the data plane, so the video plane, which drives the consumption of the infrastructure, which delivers the key content to the key people to deliver it ultimately to the consumer. And so those are the 3 sections of our presentation as we move forward over this next hour. So I'm going to hand the podium over to Brandon Potter from Fox Sports to talk about the production aspect and the business aspect of the beginning of this presentation. So Brandon, over to you.
Hello, everybody. How you doing? My name is Brandon Potter. I work in post-production for Fox Sports. So let's go to the next slide here. For the World Cup, we had an interesting thing. We had 64 matches in 12 venues spread across all of Russia. There were 64 total UHD matches that we recorded. In reality, it was probably closer to a couple thousand 1080 feeds that we had to present to production to use all their content to edit and cut with. That was 2 petabytes of content that was uploaded throughout 4 weeks of the tournament, roughly. It was we ended up sending content back to Los Angeles via fast stream to be edited live in Premiere in a 10-second delay, which Mike will get into in detail. Our largest upload in a single day was 150 terabytes with 1 to 3% packet loss. So interesting business challenge that we had. Like I said, it was about 6,000 miles away from our home broadcast facility in Los Angeles. Because our bosses hate us, our entire edit facility was back in Los Angeles, where all this media was generated in Russia. And something I should point out, with large events like this, with multiple MRLs or media rights licensees internationally, there's usually some sort of host broadcast server, host a broadcast service that supplies you with all the SDI feeds and all the media and all the content that you need to work with, for live games to air and all the feeds that you need for you, the viewer, to see these feeds on Fox. So one of the biggest things that we were dealing with was time. I mean, we're working in a live environment, right? So I work in post-production in live. What does that mean? It's kind of an oxymoron. How do you have post in live? So for some context, we edit things. Sometimes you have a couple weeks to edit some packages, some features. Maybe you have a full-length show that you're working on for a couple months, and you're turning around that, and you're getting it to air. All good and well. Sometimes we have a couple seconds, a couple minutes to turn around a highlight package and play that out into studio. What do I mean by play out? Well, in a live production, there's usually a director that needs to cue a playout operator to play that piece to air. So when you've got talking heads and then it cuts to an edited piece, someone's usually physically playing that piece out. So the time that we had to work with, we didn't have the luxury of waiting, or if something failed, we had to present all this content now. And from so far away, like I said, we're a global way, 6,000 miles. Why did we do this? It's a tremendous cost saving when you could have an entire post-production facility not uprooted and shipped out to Russia. You could imagine. So we were actually, when we first walked into this, I thought, oh God, how are we gonna get all this content back? And it can't fail. As you can see here, we generated 22,000 assets that were managed and accessed by production via web GUI in levels beyond Reach Engine. Another challenge that we had is this is a temp location for the World Cup. It was stood up for us to work in temporarily. We didn't have the luxury of sitting out and standing up permanent servers and whatnot. We had to break it out down in a month, or we got there a couple months early before the event started. Security was a big one. We're in Russia. We're in a foreign country. All that content that we were generating, like I said, 2 petabytes, we couldn't afford to ship all that stuff up to the cloud in AWS and then download it with some sort of virus. So that was a big one for us, which Bhavik will get into in a bit. So this is basically how we pulled this off. This was our whole ecosystem right here. On the left, you've got, let's see here, yes. I guess you're right. We've got Moscow with our EVS playout servers, right? So that was all where everything in Moscow was really going to air for our shows that were based in Moscow. So that's where our content eventually needed to be delivered. So all this content that was being generated from HBS and all these feeds and all the ENG shoots that we were getting, we were sending back to Los Angeles. It was finished pieces, features were being cut, and then sent back to Moscow to play out to air. Something I should also mention is our home base facility, all the content in Moscow was 1080p 50 PAL. Our home base facility is 720 5994, and mixing those frame rates is a no-no. So it was very difficult for us to kind of incorporate these two worlds. And we had a couple shows going. We had our shows in Moscow with our set in Red Square. The IBC, the International Broadcast Center, where we were doing all our work, was about 40 miles away, where we had our main control room for the shoulder programming. But then we also had a show airing out of our Los Angeles facility, again in 5994. So mixing these frame rates was difficult. And using that fast stream to send, we had 3 priority feeds of the 20 or 30 or so per match that we were able to write directly to Moscow storage using fast streaming, and then simultaneously replicate that back to Los Angeles on a 10-second delay. And that's a limitation of Premiere more than anything else. So editors were able to work with that content immediately, cut with it, do their packages, and then send it all the way back to Moscow to air, which you'll see here. And this kind of outlines this. Same thing, how do we present this content all into S3 for people to access? Well, if we've got a 9-hour record, producers, assistant editors, associate producers aren't gonna wanna download a 9-hour record to use a 10-second piece. So one of our business requirements was to present this stuff, present the proxy, present the growing HLS into the stream, and be able to subclip pieces of what you need live and then send it to your editor. We used a Premiere panel in Reach Engine, in our PAM, to be able to look at these subclips that were presented and pull that in Premiere, use your content, cut your pieces, and then get it to air, whether it was airing out of the Los Angeles production or back in Moscow, which is pretty incredible. So the key to this, we called our Fox Sports Charlotte facility Little Russia. in around March, our road to Russia started really then, when we stood up and simulated everything that we were going to do in Russia. We didn't want to get to Russia and realize that something was broken. I think overnight is 2 weeks from the United States. So we stood up everything, and we ran all our network connections from Charlotte. The only piece that was missing was really Moscow. We ran it through Frankfurt, and then back to AWS West to be able to see, what latency are we working with, how's this going to work. Right here, you got Dave Norman in the middle from Telestream, kind of, pointing out some of his servers. Those were the encoders that we used to take all the SDI feeds that we knew we were going to get, up to, I think, 64 a match, turn those into 1080-50 AVCI 220 megabit streams, routing to our storage, and then with the fast 3 or 4 fast streams that we were able to send back to Los Angeles. And that was the hardware that was really doing it with their tight API integration with Aspera. It was pretty amazing. That was Telestream. And then over here, kind of for some backstage of really what was happening in Russia, this was our main ingest room. This was basically air traffic control of all our media, all the feeds that were presented. On the top row here, you basically have monitoring. Those were all right now, a lot of them are in bars. This is where we could see, what's coming down those lines, what channel is it being recorded on in Telestream. This middle row, this was kind of key right here. This is where we recorded, and our scheduler was really set up. We needed a way to schedule, like I said, it was probably between 3,000 and 6,000 feeds throughout the 4-week tournament that we recorded. We needed an easy way to do that. Telestream really came through in the clutch when we had a vendor drop out with the scheduler to create something that we could do this, a little bit easier than scheduling one at a time and crash recording every feed. We couldn't do that. We actually ended up ingesting a CSV document that's based on times and durations that would auto kind of schedule these feeds, which is pretty great. And then down here in the middle, these are the media operator kind of stations. And this is where it all kind of went down. This is where transcoding would potentially happen if we needed to send files to EVS for playout and get files back to Los Angeles. And the next slide here, this is basically how all the editors and producers, well, I should say the producers, were accessing all their content. You could see here in the middle, you've got the video player. You could subclip, set in and outs. You could search. One of the interesting things that we had to do and why we did this, really, HBS provided us with all the content that we needed, and they actually had a great PAM. The big caveat to that was it was only available in Moscow. So we basically took all the media that was being generated by them and put it up to S3 and made our own. And this was also for our own archive. They had some great metadata that was linked to their media that we would dump and then ingest into Reach Engine, which you see here, to present to everybody. But again, it was pretty wild. I think at some point we got to Russia, and even in Charlotte, we didn't get to fax everything out end to end. There was certain technology that when we got to Russia, it was out of the box. We had to kind of cross our fingers and hope it worked, and everything really came together. And like I said, we didn't have enough time. From the end of the final, I think we had 7 hours before power was shut down, lights, and they were ripping things out. So if we didn't have all our content uploaded, like I said, it was 4 weeks, 2 petabytes. If we were at all behind on that content, we didn't get up to the cloud, it was gone forever. The storage that we're using on-prem was getting broken down. It was actually rental and shipped somewhere else. So there was really little room for failure there. And then next, I think I'm going to throw it back to Mr. Bavik to take you through kind of the deep dive into the AWS infrastructure.
All right. I think that's a super interesting viewpoint from a customer perspective, especially as we provide the infrastructure components to service all of these users. The different stakeholders, I think, is extremely wide. And if you're involved in production yourselves, you'll know the requirements that you have from an editing perspective and the nuances of your editors and the applications that they use and the on-prem storage. And so this next section here is I'm going to talk about the infrastructure components that we used for this event. And I think what's unique about the World Cup, say the men's and/or the women's, is that it happens every 4 years. It's in a different country every time, and it's extremely high profile, very high cost to license. The user experience is increased every 4 years between SD, HD, UHD, HDR, many different aspects. And so The ways in which I think Fox and the partners that supported them, and we in turn supported them, have sort of thought differently about approaching an event like this is hopefully something that can be reused by yourselves from a learning perspective. And again, that's why I think it's really exciting to be able to talk about these type of things as we look forward about ways in which we can think about live production and or just live linear in general. So just to recap the stats of the event, 4 weeks, June 14th to July 15th, 64 games sourced in UHD, HDR. Fox Sports wanted the ability to essentially edit within 10 seconds of something happening in Moscow. So that's in LA, to have the feed, to have the content, to do an edit, to reinsert that back at the direction of the producer for that specific game or match. And then they accumulated 2 petabytes of content. So that's those 64 games recorded in their entirety, plus different camera feeds, all recorded. And then 22,000 individual assets that were also accumulated during the event. So the trade-off here is, do you build this infrastructure, or do you use and leverage something like the AWS Cloud to give you this flexibility in terms of scale and predictability, or do you do what has historically had to be done, which is you build for peak and you estimate, and then you contract your SLAs based on the capacity that you have. So the business requirements as part of supporting this were equally complex. So what I showed you before is what was achieved during the game. Going into the game, they had these business requirements. They would have to receive all of those 64 match feeds in Moscow at the host broadcasting service. That would be handed off in SDI. They would need to record all of those matches in real time in Los Angeles. So that's that 6,000 miles, 10,000 kilometers, 180 milliseconds away. There was a requirement to archive everything that came in. There was a requirement to virus scan every single asset, file-based asset that came in, whether it came from a trusted or untrusted source, before it reached a production environment. And they had to support the 3 edit-at-home workflows, which is the ability to do live editing. And so here it says less than 30 seconds, because the original business SLA was to try and do a live edit within 30 seconds of it happening. They actually achieved 10 through this, through what was created and engineered. They needed to support live subclipping and do post-game editing for all the marketing, promos, replays that might be done post-match and as part of the fan experience through mobile or web and things like that. So when we look at the matrix of solutions, this slide is meant to just give you an insight into some of the components that will be created. So we start at the top at the content production layer. Brandon had mentioned that their editor of choice was Adobe Premiere Pro. They had their production asset management system was Levels Beyond. On-premise, both in Moscow and in LA, they had Harmonic Media Grid and Quantel storage for different aspects. At the AWS component, we were using core fundamental building blocks provided by the platform. So Amazon EC2, Amazon S3, AWS Direct Connect, Amazon Lambda, SQS for some of the serverless functionality that we'll see shortly that was created to really add a dynamic workflow to the production aspects. And then below, again, driving the consumption is all of the video transport, so the data plane from the video perspective. And so that was transport provided by IBM Aspera, transcoding and packaging provided by Telestream on-premise, and then also transcoding, packaging, and orchestration provided by Telestream, both on-premise and through their cloud-based solution. So these are just some of the components that we'll sort of piece together as we look forward. So you can look at this in terms of a matrix. You've got a vertically integrated editor to storage to content being written to that storage for production, or you can go horizontally and look at the network layer, or we could look at the video layer. And those are the things that we're going to look at next. If we look at the WAN topology, on paper it looks super simple. We've got Russia, and we've got LA, and we've got a long distance in between, and we've got to carry all of those live feeds, all of those raw camera feeds, all of those files from one place to the other, and meet these business SLAs. What's interesting below this is actually how the video transport layer drove the WAN topology. So this next slide is a slightly different view on this, which is what's driving the consumption of the network and what network decisions were made in order to transport the video that we knew was going to be handed off. Again, those 64 streams in SD with the camera feeds plus the files. And in the top, as you look at it, top right, are the business SLAs around the production. Less than 30 seconds, do subclipping, allow for post-game editing. So if we start off in Moscow, we will receive host broadcasting services from 12 different venues across Russia. All of the games will be played. Those will come in through SDI. They're terminated by the Telestream appliance that has Aspera integrated. So at this point, we're doing an SDI to IP handoff in real time. Output on the over IP now is their live HLS proxies and the ISO camera feeds at the bit rates that Brandon mentioned earlier. That's going to go across the wide area network and be terminated at the other end in the AWS cloud. Specifically here, we're using US West 2, which is our Portland or PDX region. So in there, we've got, we've got Aspera terminating the transport. We've got it writing to S3. We've got Telestream Cloud reading from S3 and doing whatever processing is required for the workflow. We've got a next stage, which is doing virus scanning on file-based content, which is also reading and writing from S3. And then we've got the production asset management system, which is pulling from S3 content that has been validated for production and moved from staging into a production environment. So you'll see here one of the key themes we talk about a lot from the media and entertainment perspective, which is a content lake. And what you see here is a great use of S3 for that, which is it's agnostic to the workflow. If you can support a read and write to S3, you've got multiple sources reading and writing and creating a very dynamic, scalable, and changeable workflow based on the business needs. Everything's reading and writing from the same storage point, but all of those different processes could be provided by different service providers. In the case of here, it's both Aspera and Telestream from the cloud perspective. We've got Reach Engine being run as a managed service and on-premise. And we've got a Fox Run antivirus storage and business process function, all reading and writing. And then the third area we've got now is the Fox Sports headquarters in Los Angeles, which is where we have our editors sitting with their workstations, with local storage, all looking to receive their content during the match and during the event. And so this is the video workflow that then will drive the network diagrams that we'll see next. So what we have here is a view of the network topology facilitating the transfer of this video and these files. So if I look at it from right to left, if we start in Moscow, we've got all of the content coming into the Moscow host broadcast services. We've got those Telestream, Aspera appliances transforming SDI to IP. We've got a direct connect that goes from Moscow to the AWS Frankfurt region. And Fox chose a 10 gigabit per second direct connect, Frankfurt to Moscow, or Moscow to Frankfurt, depending on which way the traffic's going. And then we've got the AWS backbone, which carries that traffic to the AWS US West 2 region, which is the Portland region. Then we've got connecting from Portland to LA to 10 gig links via direct connect that actually route through Las Vegas here from the direct connect POP perspective. So this creates the network backbone for which the video and the file-based content was transferring. And so there were trade-offs made here as to redundancy. So I think from a cost and business perspective, 1 gig was chosen for the for Moscow to Frankfurt. And because of Fox's wider use of AWS, they had the 2 redundant 10 gig links between LA and the AWS US West regions. So as a backup, you can default to public IP as the default transport should your primary links fail. And so there was public IP transit routes that were put in place to do both from Moscow to Frankfurt and also from Moscow straight to LA on the lot. And so this way, there was ability to balance cost and short-term high bandwidth infrastructure, especially those direct connects only for the duration of the event, but allowing you to have redundancy and failover built into the system. The other decision taken here was, when you look at file-based workflows or live-based workflows, can you work in a proxy environment? So if you could default to, if your primary connections fail and you have to switch to public IP, perhaps your bandwidth is lower, but if you've got a proxy-based workflow, perhaps that allows you flexibility and a design decision and a cost decision as you're beginning to build out your systems. And so this way you have both. You have primary over direct connects and over high bandwidth links, and then you have secondary failovers over public IP. So as we look at this in a little bit more detail, we've got multiple components and demarc points that set up the infrastructure. So here I'm going to draw lines, right? So we've got the host broadcast services from which the direct connect is egressing to our AWS Frankfurt region. And so that is a dedicated line at 10 gigabits per second, which is from which we are rerouting that traffic now to the Portland region over the AWS backbone. And so that is using Direct Connect Gateway. It's using Direct Connect as the ingest point. We're using BGP routing to ensure that we're getting from source to destination, which in this case is the Portland region, where Aspera is terminating that IP transfer and writing to S3 in S3 in Portland. We've then got a secondary 2 10 gig links that come out of Portland to the Fox slot in Los Angeles, and those are the redundant 2 10 gig links. And so these are the demarc points that were constructed to facilitate the live and file-based transfer of content as you moved from Moscow to LA to support those editors and to support the in-game production requirements that were required as part of the experience that Fox was looking to deliver to its audience. And so here, within these lines, you also see failover points. So you'll see between on the lower part of the screen, between Moscow and LA, you'll see a VPN connection that can be failed over to. So all of the routes, all of the way this was constructed allowed for multiple failovers with different cost profiles, right? So again, we've got one 10 gig link that allows us to fail over to IP. We've got 2 10 gig links in the US. We've got multiple paths that the traffic can move between. And we've also got flexible workflows that will allow us to modify in real time, potentially, what can be done and what needs to be done should network connectivity go down. Within now the AWS region in Portland, we've got now the AWS architecture piece. So this is now gluing together the different VPCs that are used and configured and stood up to support the applications that we've spoken about through this session. So within the VPC, the main VPC in Portland, we've got multiple VPCs that host production and development environments. And so for the Reach Engine deployment, they had production and development, which allowed them to test the way in which they were going to do both file and live-based workflows and how that was going to be presented to their editors, how the asset management system was going to register assets, which I will get into later. We had a VPC environment for the Aspera components, a VPC environment for the Telestream components, and then we were using standard building blocks like Amazon S3 and AWS Lambda and simple queuing service to really build the glue and the orchestration around the workflow so that you could automate a lot of this from end to end. And those VPCs were all running in Portland with all of that traffic, for the most part, being routed through Frankfurt over the AWS backbone to the US West 2 region. And then in green, you'll see the different paths that we have to read and write data. So everyone needs access to S3. So you've got that either directly, if you're in the same region, or over public IP, or over Direct Connect. You've got the LA facility for Fox Sports connected, and then also with failover. And then you've got direct connects. So you've got a network connectivity between Russia and LA, but that's over public IP. So what you see here is a network design that supports redundancy within the file-based live workflows, and then the VPCs that are constructed to then run the different components and the different service provider technologies to actually glue everything together. And so this explains hopefully a little bit about the network infrastructure, what was powering it in terms of the video and live, and then the way in which the VPCs were constructed to ensure that each different application provider had a segregated but permission-based control over the content they were writing. So if we move from the live piece to now the file-based workflow, what I mentioned earlier, and Brandon mentioned also, that cumulatively over the course of the event, 22,000 assets had to be run through antivirus scanning before they entered the production network. So that was every piece of file-based content. And I think a lot of the content here is around metadata, clipping, sourced from different people, but it's all to support the production and allow the producers and the editors to know what components are necessary for what tasks they're going to do. And so to build an infrastructure to do 22,000 assets of antivirus scanning requires quite a lot of compute and a lot of transitory storage but it's also essential from a design perspective to air gap the content prior to being antivirus, or being virus checked, and then moving it into production. So why not do this on premise? So there are a number of reasons. So the three main ones were, firstly, this was a peak event, 4 weeks for the duration of the event. There was limited on-site capacity, so it could have been done on premise, but that would have compromised the existing business conditions. And then again, there was a necessary need, given the source of the content, which is unknown, even if it's from trusted contributors, to do a full antivirus before you bring it into production. So what was built was a mechanism to automate this fully in the US West 2 region. So that was essentially writing everything to S3, it being quarantined by default, and then running antivirus against that content, and then moving it into production. And so that's what I'm going to talk about next. So what Fox did with its engineering team, Fox Sports did, was to automate this antivirus workflow using multiple components of serverless and compute and storage. And so this is the run-through of what the antivirus workflow looks like. So we've got Aspera reading files in Moscow, writing them, sending them over the wide area network, over Direct Connect, and landing them in S3. So step one is Aspera is going to write the files, these 22,000 assets, to S3. We're going to use S3 notifications to trigger various things post-write. And so S3 notifications drastically reduces the complexity in determining if something's there. You don't have to scan the folder. You can just listen out for a notification, and you can do the next steps. So in the case of this antivirus scan, the next step was to create a queue, a queuing system, so simple queuing service, to basically create a queue that triggered a new asset list. And so as each asset was written, SQS through the S3 notification will be updated with the new asset. That asset was then transferred to EC2, where the antivirus scan was run. That EC2 group was in its own VPC. So was the write access to S3, so that you can control both. Within the EC2, there was an auto-scaling fleet to basically scale up the EC2 processing nodes to process the queue based on incoming traffic. And what's unpredictable there is you don't know how much content is going to come in every hour. It might be a very popular game. There might be a lot of metadata. If it's a very popular team, there's likely a lot of information that comes in about the players, both historical and current. And so the auto-scaling group would scale up and down based on the SQS queue to do an antivirus scan. Once the antivirus scan was done, the results of that were sent to AWS Lambda, and AWS Lambda processed that result to determine what the next step should be. So did the antivirus pass? Were there any flags? Could we move that asset from quarantined into production? And so SQS, so once Lambda processed that output file, it would update a secondary queue to do the antivirus pass. So now you've got a list of assets in real time that have passed antivirus that are now picked up by the asset management system. And so what's unique here is that we're using one S3 bucket. We're not worried about transferring between buckets. And we're only going to register assets in the asset management system that have passed an antivirus scan. But everything is in the same S3 bucket to begin with. So that's actually, it's a simple way to do a very complex task without having to do a lot of complex rule management specifically. So this secondary queue would be something that the Reach Engine production asset management system would listen out for. It would listen out for assets that it could register in its system. It would register those assets, and those assets would then be presented to the production systems as assets that were valid for production and not quarantined or pre-virus scan. And so this system was built uniquely to do this antivirus scanning, offloading all of the infrastructure requirements on premise, but doing it in a fully automated way. So everything here is trigger-based. It's got queuing mechanisms. It's using auto-scaling. It's integrating with third parties, specifically Aspera on the right, and Reach Engine as the asset management system from the production perspective. And it's allowing a very scalable, high-scale, short-term environment to be stood up. And what this actually represents is potentially a different way of doing many of these things from a live production perspective. Again, because your primary concern here is twofold. One, is the content secure? There was also a decision made that all live content was secure because the appliances and the feeds were controlled by the customer. Any content that came in from third parties, by default, was going to go through this mechanism. And so In these last few slides, I've gone through many things. One is the wide area network. One was what drove the video transport to consume the networking, how the networking was designed and what failover components were there, and then how, in parallel, the file-based workflow was built to drive a serverless workflow to ensure security and timeliness around the processing of that content and the availability of that content in the asset management system. So next, I'm going to hand over, so one final piece is that this yellow line, is going back to S3. So you'll see S3 is still the same common source. It's the content lake for this entire workflow still. We're not moving necessarily between buckets. We're not making it more complex. We're leveraging the notification systems and the asset management system to really drive the logic that is presented to the production people. So next, we're going to talk about the video transport and processing. So this is what fills the pipes and fills the S3 storage and delivers those assets as part of the final integration. And so with that, I'm going to hand over to Mike, who will take us through part 3 of this presentation. Thank you.
Thanks, Bhavik. All right. So we're going to talk, go into a little bit of detail about what we did to actually overcome some of the limitations that we actually had going from Moscow to the west coast of the U.S. So as has been mentioned, we actually brought a bunch of content back to the Fox Sports facility, in L.A., but then a bunch into S3 directly as well. And that was, as Bhavik mentioned, that was U.S. West and Oregon. So I just want to recap a few of the challenges here. So time and distance. Brandon talked about this. And I'm going to talk a little bit about how time and distance affects some of the technical challenges that surround that with regard to actually moving the data. Security, of course, Bhavik just went through a very good explanation of the detailed workflows for virus scanning and that kind of thing. And then the content management as well. I will say that 22,000 assets is a lot of files to be moved, a lot of data to be moved, and going into this, we thought that we might be transferring about maybe 1.7 petabytes between Moscow and Russia, or between Russia and the west coast of the U.S. And what happened was we ended up with about 2 petabytes. We only had 1 petabyte of storage on site. So as you could see that we absolutely had to get a lot of that content off. We didn't have room to store it all as we went throughout the course of the tournament. So let's talk about the time and distance as it relates to TCP-based technologies. With TCP-based technologies, there's just a fraction of, you can only get a fraction of the throughput that might be available because of packet loss and latency. So anytime you have distance, packet loss increases, latency increases. It's just a factor with regard to distance. And TCP, of course, wants an acknowledgement for every packet it sends, right? So and it has this thing called a window size. And this TCP window size is basically allows TCP, the protocol itself, to actually to acknowledge or affirm packet reception with just a single round trip. So this window size actually buys you a little bit, but what happens is because TCP wants an acknowledgement for every packet it sends, as it runs into situations where it's not getting acknowledgement in the time frame that it wants it in, starts shrinking this window size, effectively artificially constraining your bandwidth. So we can actually look at a pretty simple formula that we use quite often to look at the obtainable throughput with TCP. And that's the number of the bits through second throughput is equal to the window size in bits divided by the latency in seconds. So if we look at an example here, not unlike the conditions that we had in Russia, between Russia and the west coast of the US, if you consider about 200 milliseconds of latency, 2% packet loss, and a 64K TCP window size, and if you look at the formula down at the bottom, you can see that we're only able to get, over that distance, about 2.62 megabits a second. Okay, now, so we have to overcome that somehow, and then you factor in packet loss, and you're even worse. So again, just by looking at this equation here, you can actually tell that increasing bandwidth isn't going to do us any good. We can increase bandwidth till the cows come home, and we're still not going to help our actual throughput. So what can we do? So in all three of these things here, under what can be done, they all kind of work together. So the first thing we can do is minimize startup time. So the amount of time that that it takes to actually start processing the data. It's been mentioned that we had a couple of workflows. I'll talk about those in a little bit of detail. One of those being a live edit, so camera to edit. The requirement was 30 seconds, as you could tell, but we ended up being able to do that in less than 10 seconds. From Moscow to LA. The second thing is minimize the bandwidth overhead. So what we want to do is make that bandwidth overhead as close to the actual packet loss as possible. There are technologies like forward error correction that actually send extra data to kind of try and assure that you have some padding there. But that's not good enough for us. In fact, forward error correction typically is about 25 times more payload than our fast protocol is. So I'm not going to talk a lot about our protocol, but that's the big thing is we want to minimize that overhead, and then reduce the number of retransmissions. If we start pounding the network and we can't get the content there as fast, no matter what you're using, you're putting extra data. You're putting extra data there on the network itself. And so you're contributing to the problem, right? You're exasperating the problem. So the thing that you want to do is kind of apply things at a constant and steady rate that's sustainable. Okay, so just continuing with time and distance here. So optimizing the pipeline. We didn't want to bring the assets in and stage them. For example, we talk directly into S3. We don't want to just stage them, on a file system and then move them into S3. As these files are growing, as we're bringing these in, we want to write them directly to S3. So that's something that we've spent a lot of time and effort making sure that we eke the best performance out that we can. And so we, of course, use the S3 multi-part API to actually spin off the optimal number of threads and so forth to try and maximize throughput. I'm going to talk a little bit about the per server, per instances, and per instance throughput and that kind of thing. And there's just some things you got to keep in mind here. Next is direct server-to-server transmission. Of course, you don't want to have kind of a stopping off point in between. You want to make these transfers happen from location A to location B. So we had servers in Moscow, and Reach Engine asset management system was actually sending API requests to the servers in Moscow and in US West in Oregon, and was actually initiating server-to-server transfer, so it didn't have to go through a central point. It was just saying, okay, server in Moscow transfer directly into S3 or vice versa. And then the next thing, and I can't emphasize this enough, that we don't want bespoke workflows. We tried to make it so we had the direct API integration. This direct API integration goes for not only the integration with the asset management system, but also with the integration with Telestream Lightspeed Live. Live Capture is the Telestream product that actually took the HCSDI feeds in and produced these growing files. I'm going to talk a little bit about how we did that, because that ended up being kind of cool as well. So if we look at WAN transfer speed and what we could get out of each instance. So if you take a C38 extra large instance, you have limits on what you can actually push through that instance on a per stream basis. So we can only get about 2.8 gigabits a second per stream coming in. Doesn't matter where the origin is from. At each stream, you can only get a maximum of about 2.1 gigabits per stream. Now, these actually came from actual performance numbers. And when we got to Moscow, we actually, that's one of the points that I'll make a little later on, is that expect the unexpected. So when we got there, we actually, tested and did a lot of optimization and looked at things and to see what we actually got. The staging environment in Charlotte that Brandon mentioned was also, very, very helpful. So then, with a single machine though, and multiple sessions, we can only get a maximum of about 3.5 gigabits a second. So, we needed more than that. So what could we do, right? So what we ended up doing is you not only have to scale out the back end, the number of servers accept things, on the server side, but also on the local side as well. And so we actually stood up 3 servers. Three servers in Moscow, and we kind of balanced the throughput. And it's not just about balancing, and we can go into it if you want to see me afterwards, after the talk, we can do some Q&A, and I can explain some of the things that we did to optimize things there, because it's not just about how many transfers does a machine have going on, or how many sessions and that kind of thing. There's a few tricks that you can do there. So now security, again, is very important. Not only the security around the virus scanning, but also session authentication. So with we actually have session authentication, which is uses SSH. So triple DES was used there. Transfer authorization using tokens and access keys, and so forth. So we actually made sure we had a very secure environment. And then of course the data itself was encrypted, in transit. So using AS encryption, and then also with the protocol, there's an MD5 hash that's applied to each datagram, and then that's verified on the other end. So we actually verify the integrity of that data as it's being moved as well. I did mention API integration. Like I said, with Reach Engine, it's very important that we had that tight integration as opposed to something bespoke. Like I said already, we had server-to-server transfers. We had the 3 servers in Moscow, and then we auto-scaled the cluster, in AWS. And then in LA we had SAN storage, shared SAN storage that was actually used for that full-res live editing. Just a couple of details about the live edits. They were 220 megabit video streams. You had audio to that. You're pushing 250 megabits a second. And we had a 1 gig. It was mentioned there was a 1 gig pipe that this was running over. So, and they're doing about 3 streams per match. So we were QoS at about 800 megabits. So you see, we didn't have a lot of overhead there, and we were able to keep up live. I'll talk a little bit more in a second about how we did that. The key design principles, just optimize, optimize, optimize. We like I said, when we got to Moscow, we actually had the first couple of days, we kept popping the circuit, right? We were pushing close to 10 gigabits a second through it, but we kept popping the circuit, and it turned out to be a network provider issue there, and we finally got that worked out. But you never know what you're going to run into. When we talk about the integration, and I'm a big fan of API integrations. I've focused a lot of my career at Aspera around helping people integrate our technology into their applications and workflows. And the reason that I'm so passionate about it is because we have, you want that feedback. You have a bunch of different pieces of hardware and a bunch of different workflows and pieces of software and so forth, and you want that feedback all the way to be able to push back all the way through to the source as well, so you can adjust. So for example, as we were with a couple, there's 2 main workflows that I'll talk about. One is the live edit workflow. The other one is our live subclipping workflow that was done. With both of those, it wasn't just enough to just assume we were going to get everything there. I'm happy to say that we actually kept up much, much better than we ever thought we would. By the time the World Cup was over, we basically had all the content off-site and up into the cloud, so up into S3. But with that excuse me, with that in-application feedback, we were able to accommodate for situations where there might have been an issue. Now, fortunately, we ran into very few issues during the course of the event, but we always maintained a local copy as well. So at the same time, the streams were actually creating files that were being pushed remotely to LA or directly into S3, local copies were being stored as well. So if there ever came a time, let's say, something happened, our bandwidth dropped to, to substantially lower than we needed to carry out things in real time, because of that local copy, we could actually push that feedback back upstream and we could actually start pulling from that local copy, and as bandwidth increased, we could actually catch up to where to live at any given time. Like I said, we didn't really have to do that during the course of the event, but we had it there just in case. Likewise, we made sure that we handled conditions where there might be a network interruption, complete network interruption as well. And like I said, we had the local backup copies as well. Expect the unexpected, and I've mentioned several times, avoid anything bespoke. So let's take a quick look at the live subclip workflow here. I'm sorry I can't really point a pointer at the screen, but just bear with me a little bit. We're going to start down at that bottom right-hand corner. And that bottom right-hand corner, you can see the very lowest set of servers there is Telestream. So that's Telestream Lightspeed Live. And then the very bottom line, that yellow line that's there, is excuse me, is our direct live edit workflows. I've talked a little bit about those, so we'll just kind of ignore those for a second. But the live edit workflow, what's happening there is we're pushing these files, these HLS streams, so these the manifest and segments into S3 as the event was going on, and that HLS stream that was being pushed, that was a 5 megabit stream, so it was kind of a low res proxy that was being done. But what happened is that allowed the Reach Engine had a player built into it, could actually pull directly from S3, so they could look at that low res proxy, and they could set in and out points, and they could set say I want a clip from this point to this point, and what happened is, and this is kind of on the right side, a set of commands got sent to Telestream Vantage on site, and then Vantage would actually create that clip at the same in and out points out of the high-res version, and then Aspera would transfer that back up into S3 bucket, and all of a sudden you have, in very little time, you have a full-res clip that was generated by somebody that might not even be have great connectivity anywhere. All right, so with that, I'm going to ask Brandon and Bhavik to come back out with me.
Bhavik's going to hang back.
All right. Okay, I'm going to have Brandon with me. I guess Bhavik's going to hang back. All right, so let's talk about some of the lessons learned. Brandon, we've both talked about, Little Russia, Charlotte. Without that, we couldn't have done it, right? I mean, simulation was key, right? I mean, I remember the first time that we saw all the stuff working, and there was a lot of joy in that room.
Yeah, a lot of high fives. That simulation was key to stand up everything to make sure the lights came on and all those connections were there.
Yeah. Second thing, collaboration. There was Telestream involved. Fox Sports, of course, was driving things. We had Aspera. We had Levels Beyond with Reach Engine, and there are a few other vendors as well. Harmonic, that Media Grid Storage was on site. And I would say that one of the keys to making something like this work, because you don't know what you're going to find when you get there. Collaboration, avoiding the walls between vendors. I think we had several early morning meetings to kind of talk about what we were going to tackle the next day, right?
Right. Yeah, you stepped out of your domain and were writing code to help us fix some of the bugs that we were seeing completely out of the Aspera world. So yeah, that team, everyone came together to kind of, accomplish our goals.
It was indeed teamwork. And this last one on this slide, track progress relentlessly. At first we started kind of tracking things on post-it notes and that kind of thing. And very quickly we thought, okay, we're going to use a tool, and we used an actual agile tool, even on site, while we were there on site, to actually track our progress. Leading up. We didn't have much time, and things were a little bit behind. The build out was a little bit behind, and that kind of thing. So we ended up having to do things, fairly quickly there. All right, Brandon, why don't you take this slide?
Yeah, one thing with simulation that we didn't really get to see was the Moscow connection. And when we got there, what we learned was streaming the HLS there was a lot of latency from Moscow. Fortunately for us, the people that were using Reach and trying to access the media were in Moscow, where the media was originating, so we had other ways to present that. But that was tough. And that we'd probably implement some sort of CDN over large geographical areas to kind of solve that problem. Like Flather said, building the right team was really paramount. Nobody said, this is my domain, I'm in Telestream, I just care about Telestream, I'm going to spare. Everyone worked together to come up with solutions when we hit a lot of speed bumps, especially when we already got there.
And you called me Flathers.
I did, yeah. God bless Slack. We had so many conversations, and it was such a good tool that we used with so many people and getting everybody on the same page to solve problems or try to weed out whatever connection issues or what were happening or whatever was happening. So
Brandon, if there is one thing that you wish you had in Russia that you didn't have, what would it be?
Hot sauce.
One of the guys that had been there a couple times actually brought a big bottle of hot sauce with him, and
yes,
came in handy.
So we leave you with a piece of advice: bring hot sauce to Russia.
That's it. I think we're wrapped up. Is that it?
Yes.
Bobak, you want to?
Looking forward, Women's World Cup. Men's World Cup was essentially a dress rehearsal, almost, for Women's World Cup. So we're going to look at that. I mean, with all this technology, I'm curious to see where we could go with virtualized, workflows as premiered, as applications start to speak object store more and more. Machine learning for metadata, so key. If you can't search the meta or the media that you're looking for when you're working with 2 petabytes of material, it's useless. Another thing we want to look at is maybe we get 5 to 10 times the amount of fast streams for the high-res bit rate that compressing it and then uncompressing it with hardware back on site or in the cloud. So on a say a 1 gig pipe, we were getting 3 to 4 feeds. Now we could probably, doing the same workflow, we could probably get around 12, I think.
Yeah, these are all uncompressed streams. So going with something like HEVC or something like that, we can actually we think about 5 times. In fact, we've had some really good luck with some early prototypes with that. So.
Yeah, tighter API integrations, just like here, the API integration with FASP and Telestream. Get us out of the watch folder business.
Yeah, there was in my notes, I have no watch folders required. I'm not a huge fan of watch folders. Sometimes they're necessary, but direct API, tight integrations was the key, absolutely, to making this. In addition to all the other things that were done, that was what made all this work. We couldn't have done it with a bunch of bespoke workflows. Heaven forbid we had an issue when when something during an event with the tight API integration, we had that feedback loop all the way through.
Serverless.
Serverless. There you go. Yes.
All right. Thank you, everyone. A quick request before you all go, if you don't mind, is please fill out your surveys. My thanks to Mike and Brandon for this. I hope you found this valuable. Have a wonderful reInvent, and thank you very much.
Thank you.